I don't get this.
Come on in.
Good? Hey Taylor.
Yeah?
I don't know how to study.
Well, you can start reading and memorizing and then reward yourself with a cupcake shot.
But Taylor, I still don't get it.
Well, think of it this way. So, Jackie's hitchhiking down the road right now. And Corey's car picks her up, which is a...
Sell.
So we go and suck her up into the car, and she comes in and she needs phosphates, and I am phosphate dealer, which is also a
ATP.
Hey.
Hey, I'm glucose.
Hey, I'm ATP, and I give her a phosphate.
ATP. Give her the phosphate group.
Hey, want a phosphate group?
Yeah! Hey!
Negatively charged.
I can't get out!
You should edit it.
Help! Now I'm fructose 6 phosphate.
You want another phosphate?
I give her another phosphate.
Phosphofructokinase.
Now I can split in two.
At least! Half, and there are two of her in the same cell sitting next to each other simultaneously, like twins in a car seat.
Dihydroxyacetone phosphate, glyceraldehyde D3 phosphate, dihydroxyacetone phosphate
Becomes
glyceraldehyde D3 phosphate.
later. Everything from now on occurs twice.
So Taylor, what happens to the phosphates during aldolase?
There's a phosphate in each hand, so each one now has one phosphate.
Energy payoff phase! Phosphate enters the enzyme triose phosphate dehydrogenase, where NAD receives an H+, releasing electrons, and that's an exergonic reaction which drives the endergonic reaction of a phosphate group from the cytosol attaching to the glyceraldehyde 3-phosphate.
That's like angry. In Jackie terms, Jackie gets hugged by Kylie, who is an enzyme.
I'm triose phosphate dehydrogenase. Oh, you're aiding in the addition of H plus to my NAD. Oxidize!
And then Jackie releases energy, which Kylie takes away and uses to give Jackie a phosphate, which comes from the cytosol.
The phosphate is now removed by phosphoglycerokinase.
Give me your phosphate. I've been paid back.
And each of them are releasing one ATP, and when the ATP is released, they both now are no longer sugars, they now are organic acids.
Now I'm...
Phosphoglyceromutase. Probably for a while.
Ow, right here.
1 o'clock.
Organic acid.
Enolase takes water from the organic acid. And when the water is removed, a double bond occurs and it has high potential energy. Jackie is
Phosphoenol pyruvate. Here, ADP, I don't want my phosphate anymore.
thanks.
100% payoff.
And when she does this, she gives her phosphates to the phosphate dealer, which then each Jackie twin gives them their phosphate, which then turns the phosphate into ATP. So now the phosphate dealer has 2 ATP, 4 ATP total throughout the whole process after investing 2 ATP in the beginning, which pays the phosphate dealer back 100% interest. You should play
Alright, so basically, the glucose spent 2 ATPs, and in the end it gained 4 ATPs. Alright, I understand this now. As pyruvate moves through the transport protein into the mitochondria, its carboxyl group that was fully oxidized gets released as CO2. The molecule is to NADH, and it is now acetate. The enzyme CoA attaches to acetyl, forming acetyl-CoA by a very weak bond. The enzyme CoA aids in the addition of acetyl to oxaloacetate, which is already in the cycle, forming citrate. A water molecule leaves from one location on citrate and joins on another location. This forms the isomer, isocitrate. Isocitrate is oxidized, removing 2 electrons and forming NADH. The oxidized isocitrate loses a CO2 molecule. This forms alpha-ketoglutarate. First, alpha-ketoglutarate loses another CO2. Alpha-ketoglutarate is then oxidized, losing 2 electrons and turning NAD to NADH. This forms succinyl. Succinyl is then attached to coenzyme A by a very weak bond, forming succinyl-CoA. A phosphate group then comes in and kicks coenzyme A out of the succinyl. The phosphate group leaves succinyl and goes to GDP. GDP and the phosphate then are turned into GTP. Damn it. GTP is similar to ATP in that it can be used to form energy. All of these actions bring succinyl to succinate. 2 hydrogens from succinate are removed and added to FAD. This turns FAD into FADH2. The loss of the 2 hydrogens turns succinate into fumarate. H2O is then added to fumarate. This forms malate. Malate is then oxidized, losing 2 electrons and turning NAD to NADH. This brings us back to our first molecule of oxaloacetate, and we start the process again.